All right, welcome back, and we're in 12.2 Part 2, where we learn about a rule that deals with a chord. Okay, so the rule basically states that if you have a chord, the diameter of a circle will always be a perpendicular bisector, which means, as I'm writing this, if you have a circle and there's a chord, when you draw a diameter, that doesn't necessarily mean there's always a diameter there, you will have to know that it is a perpendicular bisector. And that bisector, you will add the right angle mark, like we're always doing, adding the right angle mark. And then we're also going to add the congruency marks, because it is not only perpendicular, but it is a perpendicular bisector, which means this and this are cut into equal pieces. The arc is cut into equal pieces. And if you were to draw, that means if you were to draw, I'm fudging it, that's why I put the dashed lines. If you were to draw, I'll put that there, and we'll make it a little darker here, so you can see a little better. There you go. And if you were to draw two more radii, the angles would also be bisected, that central angle. Okay. And as you can see, we have right triangle work. And we've talked about this before, that when you're doing right triangle work, there's certain sides that you know for a fact will always be. The radius is one of them. The radius will always be the what? Correct. The radius will always be your hypotenuse. So if you know what a radius is in a circle, then you'll be able to understand what or where to put your measurement for your hypotenuse. And then you would do right triangle work, whether it be sine, cosine, tangent, or 30, 60, 90, or 45, 45, 90, or a squared plus b squared equals c squared. All of those right triangle work problems would still exist. They're just going to give you different pieces of this puzzle. Right? Now, if you see that a line is perpendicular bisected, then what is doing the bisecting has to be a diameter. So you've got to know it forwards and backwards. So for example, the diameter is the only thing that will be a perpendicular bisector to a chord, no matter where it is. So if I draw a circle like this, and I put a chord, even if the drawing's off, and I go like this, and I tell you that it's a perpendicular bisector, then you have to know that the center is there. That's what you're adding. Why? Because the diameter is the only line segment that will be perpendicular bisector to a chord, ever, in a circle. Okay? So those are the things you're supposed to know. Now, what are the questions they're going to ask you? Well, they're going to ask you for this piece. They're going to ask you for this piece. They might give you the entire chord, and then you have to cut it into two equal pieces. They might give you an equation for this piece, an equation for this piece. You put them equal to each other. Why? Because they're equal to each other. Okay? That's what bisecting means. All right, so let's look at a type of problem. Let's say you have a circle, okay? And on that circle you have K. Okay, then you have L. And then you have M. You know LM will make a chord. And I tell you that LM is 14. And then I go ahead and tell you that this segment here is 3. All right, so now you're looking at that picture and you're going, okay, what could the question be? Well, the question is going to be, what is the length of K to L? Okay. And that would be, what is this length? All right, well, I know I'm going to do right triangle work. Hopefully you know K to L is called a, correct, radius. So I draw my right triangle, and I know my radius is going to have x. And I know one of my sides of my right triangle is going to be 3. What is the other side of my right triangle going to be? Well, let's look at the original picture. The rule we learned is that the line that is perpendicular to the chord is a bisector. So that means it's cut into 2 equal pieces. So I can go ahead and do that, which means it's 7. And then I use my Pythagorean theorem. 3 squared plus 7 squared equals x squared. This is 9 plus 49 equals x squared. This is 58 equals x squared. You square root it. And you get x equals 7.6, or around there. Okay, approximately. So because we're rounding, we use the approximate sign. All right? So it still ends up being a lot of right triangle work. They just give you different measurements, and you have to split them into pieces so that you understand what those pieces are. Please remember again, when they give you a number, the number will go for the line segment wherever they put the number. So notice I put 15 in the middle of the chord. That means it was the length of the whole chord. If I had moved the 14 and actually put it underneath the 1/2 of it, then that means that segment would have been 14, which means the whole chord would have been 28. So you have to pay attention to where the numbers are on your picture. And a lot of times they'll draw an arrow if it's not obvious. All right, so again, sometimes you'll be finding the piece, sometimes you'll find that 7, and then have to double it to get the chord. Sometimes you'll have the chord. You'll have to have it, okay, or know that you're going to be cutting it into 2 equal pieces in order to get this, so that you can do the right triangle work to find the radius. So they're going to give you different pieces of that picture. Your job is to find the pieces. Now remember, the radius is always the hypotenuse. They can draw the radius like this. Your job is to move it. You can move it anywhere you want because all radii are the same. And when you move it to here, it's now the hypotenuse of the right triangle. So it doesn't matter where they put the radius, you just move it like the hands of a clock. All right? Well, I wish you luck. Go ahead and do the got it, and then tomorrow when you come into class, I will have the got it up on the screen for you, the answer, so you can check your work. All right. Have a good day.